Hi everyone, this video is on periodic trends. Hopefully you are starting to see how useful the periodic table is and how we can use it for coming up with configurations, for getting valence electrons, looking at reactivity, properties, and so on. So these are just a couple more trends that we can use from the periodic table, and we're going to look at atomic size and ionization energy. So an atom size can be related to our periodic table, and it increases. The size of the atom gets bigger as you move down a column. Okay, so think about this. As you move down the column, you're getting more and more energy levels around the nucleus. So obviously the atom gets larger and larger and larger as we move down the periodic table. However, some students don't think about this. They think as you move across from left to right on a periodic table, they think that you would be increasing in size. Okay, you're actually decreasing in size of the atom as you move from left to right. Okay, the size of the atom decreases across a row because your number of protons are increasing, right? So you've got, let's put in some here, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I didn't mean to do that. That would be 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so those are just atomic numbers there. It doesn't really matter, but it's just showing you that they're increasing from left to right. So as your protons increase from left to right, okay, your protons are positively charged, okay, and they're in the nucleus, okay, but your valence electrons are negatively charged. So as you have more protons, you have more electrons, okay, and so they pull each other closer together because positive and negative charges attract. Okay, and so instead of increasing in size, we decrease in size. Okay, so when I look at the periodic table, you can think of the trend this way, but you can also think of that anything up in the right corner here is going to be the smallest, and anything over here is going to be the largest. Okay, so that's a good way to think about it, because if you increase as you go down, then this is going to be smaller, and then if you decrease in size as you move across, then anything that's further to the right and up high is going to be smaller than anything that's further to the left and down low on the periodic table. Okay, atomic size and ionization energy go hand in hand, so once you look over this a couple times, hopefully it will make sense to you. But ionization energy is the energy needed to remove an electron from a neutral atom. So here's sodium, it's a metal, and you'll learn later that metals easily give up electrons. Okay, and so sodium is in group 1, and that means it has one valence electron, and so it easily will lose an electron. Okay, and so the energy needed to do this is going to be pretty low for sodium because it's a metal. But ionization energies decrease down a column. So as the valence electrons get further away from the nucleus, okay, from the positively charged nucleus, okay, then you're going to decrease in the amount of energy that is needed to pull an electron away. So one way to think about this is the larger the atom, the more energy levels it has, right? Okay, so the electrons out here on the larger atom, okay, are going to be easier to remove. Okay, so that's what they're going to have, a lower ionization energy. Okay, the electrons that are further away from the nucleus. Okay, it gets harder to remove an electron as you move from left to right. So it takes more energy, okay, as you move from left to right across the periodic table. Okay, so if we think about this, if we just look at a periodic table, the way I think about this is that over here these are my metals. Okay, so they're going to be the atoms that give up an electron the easiest because they have the lowest ionization energy. It doesn't take as much energy to remove an electron. And then elements that are at the up top to the right are going to have higher, or the highest, ionization energies. All right, so let's practice these. Let's first of all, before we even practice, let's go ahead and label this again. Label what we know. Anything up here for our radius, okay, or our size, our atomic radius, same thing, is going to be small. And over opposite of it, diagonal, these are going to be large atoms. Okay, and then for ionization energy, these are going to have the highest if they're up to the far right, and down to the bottom left, these are going to have the lowest ionization energies. Okay, and it still goes along with, you know, increases or decreases whether you're looking at the column or the row. All right, so let's write out. Okay, so write these problems out. You can pause the video if you need to. The first ones we're going to arrange in order of atomic size from smallest to largest. Okay, and then we're going to come back to those and look at ionization energy. Okay, from smallest to largest. So here everything's in the same group. Okay, I don't think we used that one. Okay, so we're looking at size from smallest to largest. So if we go from top to bottom, remember our atom and its energy levels have more and more energy levels, so it gets larger and larger. So it would be oxygen would be the smallest, then sulfur, last would be tellurium. Okay. The next one we had phosphorus, sulfur, chlorine, silicon. So everything is in this row here. Okay, so this is using our trend as we move from left to right. Okay, these are going to be smaller than to the left. So the size decreases as you move from left to right. Okay, so that's going to make chlorine, remember it's closest to the top right up here, the smallest, and then sulfur, and phosphorus, and then silicon. Okay, ionization energies. So we have strontium, calcium, magnesium, beryllium, so they're all here. Okay, and I think we put in order of lowest to highest. The lowest ionization energy, these are the easiest. They're going to more readily take less energy to lose an electron. So our order is going to be this. So further we are down to the bottom, okay, of the group, they're going to be lower and lowest ionization energy, and then it gets higher as we move to the top. And then if we look at the next one, it gave us beryllium, boron, nitrogen, and oxygen. So all of these are in the same row. Okay, and so our trend tells us that as we move from left to right, the ionization energy gets higher. So this would be our trend there. We would have beryllium, boron, nitrogen, oxygen from lowest to highest ionization energy. Thank you, and I'll see you again soon.